Hello there, and welcome once again to our quiet corner of the internet, the Sleepy Wiki. As you settle in tonight, perhaps let your shoulders gently drop, release any lingering tension from your day, and just allow your breath to slowly deepen, in and out. Tonight, we're going to drift across the vast, silent ocean of the cosmos, to ponder questions as old as starlight itself. We'll gently touch upon the whispers of other worlds, the quiet possibility of life beyond our own earthly shores, exploring, not with a rush, but with a soft, inquisitive curiosity, the idea of alien facts. Imagine the immense expanse, the countless stars, each a distant sun, and the planets that might orbit them, silent observers in the cosmic dance. It's a journey into the gentle unknown, a soothing contemplation of what might lie just beyond our immediate gaze, a calming exploration of theories and observations, inviting your mind to wander softly. And if you find these quiet journeys helpful for your rest, a gentle tap on the like button, or perhaps subscribing to our channel, helps these sleepy whispers reach others seeking peace. For now, let us simply open our minds to the silent symphony of the universe's many secrets as we begin our quiet look at alien facts. We often look up at the night sky, a shimmering tapestry of distant lights, and wonder about life beyond our own blue marble. But sometimes, to understand life's grand journey, we must first look even further back, to the very beginning of everything, to the cosmic origins that whispered life into existence, not just on Earth, but perhaps across the boundless ocean of space. Imagine, if you will, the universe in its infancy, a canvas still largely blank, painted mostly with the simplest hues, hydrogen and helium. These were the only elements born directly from the Big Bang, the colossal whisper that began our cosmos. But for life as we know it, for the intricate dance of molecules that makes up every cell, we needed more. We needed carbon, the very backbone of organic chemistry, oxygen, the breath of many creatures, nitrogen, the building block of proteins and DNA, and phosphorus and sulfur, vital cogs in life's machinery. Where did these essential ingredients come from? They were forged in the heart of stars, those magnificent cosmic alchemists. Picture a star, a colossal furnace burning with unimaginable intensity, a pressure cooker beyond anything we can conceive. Within its fiery core, hydrogen atoms fuse, creating helium. As the star ages, especially larger ones, it begins to fuse helium into carbon and oxygen. It's a slow, deliberate process, like a cosmic chef gradually adding ingredients to a grand recipe. Our own sun, a middle-aged star, is still busy perfecting its helium-to-carbon recipe. But the real magic, the true spreading of these life-giving elements across the galaxy, happens when these massive stars reach the end of their lives. They don't just fade away. They explode in spectacular supernovae, a cosmic fireworks display that outshines entire galaxies for a brief, glorious moment. These cataclysmic events are not just destructive. They are also profoundly creative. The immense energy of a supernova fuses even heavier elements, like iron, gold, and uranium, elements essential for planetary cores and various biological processes. And then, with a final magnificent gasp, the star ejects its rich, newly minted contents into the vastness of space. Think of it as a cosmic sprinkler system, seeding the interstellar medium with the very ingredients that would eventually form new stars, new planets, and perhaps new life. These scattered elements don't just drift aimlessly. Over eons, gravity, that unseen sculptor of the cosmos, begins to draw them together into vast, dark, cold regions known as molecular clouds. These aren't empty spaces. They are immense nurseries, sometimes stretching for hundreds of light years, where gas and dust gather. They are the wombs of future stars and planetary systems. But within these molecular clouds, a fascinating cosmic chemistry begins to unfold, even in the extreme cold and near vacuum. Tiny dust grains, like microscopic cosmic icebergs, act as catalytic surfaces. Imagine them as miniature laboratories, where atoms and simple molecules, gently adhering to their icy coats, find opportunities to meet and react. Here, under the watchful gaze of nascent stars, more complex molecules start to form. We've detected an astonishing array of organic molecules in these interstellar clouds. Simple sugars, alcohols, even amino acid precursors. These aren't just random occurrences. They are the natural consequence of atoms interacting under specific cosmic conditions. It's as if the universe, from its very earliest moments, was inherently inclined to build towards complexity, to lay the groundwork for something truly extraordinary. As these molecular clouds collapse further, giving birth to new stars, they also form swirling disks of gas and dust, the protoplanetary disks, where planets will eventually coalesce. Our own solar system was born from such a disk, inheriting a rich legacy of elements and complex molecules. But how did these precious cosmic ingredients make their way to a young planet like Earth? This is where our icy messengers, the comets and the rocky fragments, the asteroids, enter the story. These ancient wanderers are like cosmic time capsules, preserving material from the earliest days of our solar system. Many of them formed in the colder outer reaches, far from the sun's early heat, allowing them to retain volatile compounds like water ice and a wealth of organic molecules, shielded from destruction. When the early Earth was still a molten, violent world, constantly bombarded by debris, these comets and asteroids rained down upon its surface. Each impact wasn't just a catastrophic event, it was also a delivery service. They brought vast quantities of water, filling our oceans over billions of years. And crucially, they delivered a significant amount of the organic molecules that had formed in the interstellar medium and within the early solar nebula. Scientists have found direct evidence of this cosmic delivery. Meteorites that have landed on Earth, pristine remnants of asteroids, have been analyzed in laboratories. And what have we found? Within their ancient structures, nestled among minerals, are amino acids, the very building blocks of proteins, the workhorses of life. We've even found nucleobases, the components of DNA and RNA. These aren't just simple molecules, they are complex organic compounds ready to be assembled. This tells us that the ingredients for life weren't necessarily forged from scratch on early Earth alone. They were brought here, pre-packaged from the cosmic pantry. There's an even more intriguing detail in some of these cosmic messengers. Many organic molecules, including amino acids, exist in two mirror image forms, much like your left and right hand. Scientists call this chirality. On Earth, life almost exclusively uses left-handed amino acids. Why this preference? For a long time, it was a mystery. But some theories suggest that conditions in space, specifically certain types of circularly polarized ultraviolet light found in star-forming regions, could preferentially destroy one form of these amino acids, leaving an excess of the other. If these spaceborne, predominantly left-handed amino acids were then delivered to early Earth by meteorites and comets, they could have seeded the primordial soup with a bias, providing a cosmic explanation for life's peculiar handedness. It's a subtle, elegant clue, whispering of a connection between the vastness of space and the intricate machinery of every living cell. So, envision early Earth, a young planet teeming with volcanic activity, shrouded in a dense atmosphere. It was a world ripe for chemical reactions, and into this volatile environment, an endless stream of cosmic gifts arrived. Water, brought by comets, began to pool into oceans. Organic molecules, delivered by meteorites and dust, dissolved in these waters, forming a rich, warm broth. The primordial soup we often hear about. It was in this cosmic-infused soup, under the gentle yet persistent nudge of geological processes and the energy from sunlight or hydrothermal vents, that these simple building blocks began to connect, to form longer chains, to self-organize, eventually crossing the threshold from non-life to life. The story of life on Earth, therefore, isn't just an Earth story. It's a cosmic saga, interwoven with the birth and death of stars, the gathering of dust, and the long, silent journeys of icy wanderers. And this understanding has profound implications. If the building blocks of life are forged in stars, scattered by supernovae, cooked in molecular clouds, and delivered by comets and asteroids, processes that are universal across the galaxy, then it stands to reason that these same ingredients, these same cosmic recipes, are being played out on countless other worlds. Every star system, every young planet, potentially receives these same gifts, these same molecular Lego bricks ready to be assembled. The universe, in its grand, impartial way, seems to have a habit of making the fundamental ingredients for life everywhere it makes stars and planets. This cosmic dance, this intricate chain of events stretching back billions of years, reminds us that our very existence is profoundly connected to the universe around us. It's a humbling thought, isn't it? To think that the atoms in your very hand once resided in the heart of a star or traveled through the cold vacuum of space for millennia. And if these ingredients are so common, so readily available across the cosmos, then what does that tell us about the chances of them coming together elsewhere? It shifts our perspective from Earth as a unique anomaly to a vibrant, albeit tiny, expression of a widespread cosmic potential. Perhaps as we drift deeper into the mysteries of the universe, we can begin to explore what form life might take when these cosmic ingredients mix on a different stage under different suns. But that, my dear listener, is a story for another gentle moment as we continue our quiet journey through the facts of alien possibilities. Let us journey now, not to a specific star or planet, but to the very edges of our imagination, guided by the quiet whispers of science. Tonight, we ponder a profound question. What could life be like beyond our familiar blue-green world? What forms might it take? What chemistries might it embody under conditions vastly different from our own? It's a journey into hypothetical alien biology, a beautiful tapestry woven from what we know and what we can dream. Here on Earth, life as we know it is a water-based, carbon-centric phenomenon. Water, often called the universal solvent, provides the liquid medium for all our biochemical reactions, a gentle cradle for the intricate dance of molecules. Carbon, with its remarkable ability to form 4 stable bonds, is the master builder, constructing the vast, complex organic molecules that form our bodies, our proteins, our very genetic code. But what if the stage is set differently? Imagine a world where the very air bites with a chill that would freeze water solid, a place so cold that the familiar rivers and oceans of Earth would be mere memories. In such a realm, perhaps another liquid, a cryogenic solvent, might take water's place. Consider liquid ammonia, for instance. On a world much colder than ours, where temperatures hover around 78 degrees Celsius, ammonia could flow in vast, shimmering seas. Its molecules, like water's, are polar, capable of dissolving a wide range of compounds, making it a plausible candidate for a life-sustaining solvent. Or perhaps on a moon like Saturn's Titan, where lakes and rivers of liquid methane and ethane stretch across the landscape, life might have evolved to utilize these even colder liquids, building its fragile structures within their hydrocarbon embrace. Such organisms might have incredibly slow metabolisms, their life cycles measured in eons rather than decades, moving with a ponderous grace in a perpetually dim, frigid world. Now, let's turn our gaze to the very building blocks. While carbon is indeed nature's master architect on Earth, some scientists have mused about alternatives. Silicon, directly beneath carbon in the periodic table, shares a similar ability to form 4 bonds. Could there be silicon-based life? It's a fascinating thought, painting visions of crystalline structures, perhaps slow-moving beings with forms akin to geological formations. However, silicon bonds are generally weaker than carbon bonds, and crucially, silicon's oxide, silicon dioxide, is a solid, sand and rock, not a soluble gas like carbon dioxide. This makes it difficult for silicon to form long, stable, flexible chains, and for its metabolic byproducts to be easily expelled. So, while intriguing, silicon life would likely be a very different, far less dynamic affair than carbon life, perhaps thriving only under very high temperatures where silicon chains become more stable. The universe, it seems, might have a preference for carbon due to its versatility and the stability of its compounds. But we remain open to surprises. And how would these hypothetical beings draw energy from their strange surroundings? Earth life primarily harnesses the sun through photosynthesis, capturing light with green chlorophyll. But alien plants might not be green at all. On a world orbiting a red dwarf star, which emits mostly infrared light, photosynthesizers might evolve to absorb these longer wavelengths, appearing black, crimson, or even purple to our eyes. Their leaves might be broad and dark, like vast solar panels, soaking up every precious photon. In environments devoid of starlight, life might still thrive through chemosynthesis, just as it does in Earth's deep-sea hydrothermal vents. Instead of light, These organisms would derive energy from chemical reactions, perhaps with hydrogen sulfide, ammonia, or even dissolved metals, tapping into the very geological heartbeats of their worlds. The very breath of an alien creature could be utterly foreign to us. Earthlings primarily use oxygen in respiration to break down food and release energy. But what if oxygen is scarce? Some terrestrial microbes already offer clues. They breathe sulfur or nitrates or even iron. Imagine organisms on a distant gas giant moon, where the atmosphere is thick with sulfur compounds, exhaling clouds of sulfur dioxide. Or life in the icy crust of a moon, metabolizing methane and exhaling ethane. These alternative metabolic pathways open up a dizzying array of biochemical possibilities, allowing life to flourish in environments we might consider utterly toxic or inert. The shapes and forms these beings might take would be sculpted by their unique planetary canvases. On a high-gravity world, creatures might be squat, robust, and multi-legged, close to the ground, enduring the crushing weight of their planet. Conversely, on a low-gravity world with a dense atmosphere, life might float like living kites, gossamer thin and delicate, drifting on atmospheric currents. A world bathed in constant scorching radiation might host beings with metallic hides, perhaps even mineralized exoskeletons, slowly repairing themselves from cosmic assaults. On a moon orbiting a gas giant, where immense tidal forces constantly stretch and squeeze the land, life might be incredibly flexible, its tissues like rubber, able to withstand being pulled and compressed without damage. Their sensory organs, too, would be adapted. Enormous eyes in dim light, sensitive chemical detectors in murky oceans, or even magnetoreceptors to navigate by a planet's magnetic field. And even at the most fundamental level, the molecular machinery of life could be a mirror image of our own. On Earth, our amino acids, the building blocks of proteins, are almost exclusively left-handed L-amino acids, and our sugars are right-handed D sugars. This preference, called chirality, is a deep mystery. But on another world, life could just as easily have evolved with right-handed amino acids and left-handed sugars. Such organisms, while perfectly functional in their own environment, would be utterly incompatible with Earth life, like trying to fit a right-handed glove onto a left-handed hand. Their proteins couldn't assemble ours. Their enzymes couldn't catalyze our reactions. It's a reminder that even at the molecular scale, the universe offers myriad paths for life to take. From the grand scale of planetary bodies to the microscopic dance of molecules, the potential for alien life is breathtakingly vast. Our own Earth, with its incredible diversity, serves as a mere starting point for understanding how adaptable and resilient life can be. We've seen extremophiles thrive in conditions that would kill most organisms, from bacteria in boiling acid to worms living in ice. These terrestrial pioneers hint at the extraordinary ways life might find a foothold in the cosmos. As we quietly consider these myriad possibilities, we begin to appreciate that life might truly be everywhere, shaped by the unique constraints and opportunities of each star system. And as we drift deeper into the cosmic night, we might wonder, if life is so diverse, how would we ever hope to find it? Now, as we drift further into the quiet currents of the cosmos, let us ponder a truly profound journey, the evolution of alien civilizations. Imagine, if you will, a tiny seed nestled deep within the fertile soil of a distant world. This seed isn't a plant, but the very spark of life itself, perhaps a simple self-replicating molecule stirred into existence by the gentle kiss of starlight and the bubbling chemistry of a primordial ocean. For life to begin, a planet must first be a welcoming cradle. It needs a star, much like our own sun, that shines with a steady, enduring warmth, not prone to sudden, violent outbursts that would scour away any nascent chemistry. It needs a Goldilocks zone, that perfect orbital distance where liquid water, the universal solvent of life as we know it, can flow freely, not too hot to boil away, nor too cold to freeze solid. And within this watery embrace, elements heavier than hydrogen and helium, forged in the hearts of long-dead stars, must be present. Carbon, oxygen, nitrogen, phosphorus, the very building blocks of complexity. It is on such a world, bathed in the soft glow of a stable sun, that the cosmic clock begins its slow, patient tick. Neons would unfurl like an ancient scroll. Billions of years might pass, a stretch of time almost incomprehensible to our brief lives, as that initial spark of life evolves. From single-celled organisms, perhaps tiny architects of their own future, slowly learning to harness their star's energy through a process akin to photosynthesis, they would gradually reshape their world's atmosphere. Imagine a planetary breath, slowly filling with the very oxygen that complex life would later require. This profound transformation is not a quick sprint, but a geological marathon measured in eons and epochs, where patience is the ultimate virtue of evolution. Then, one day, after countless generations of microscopic pioneers, a magnificent leap might occur. Perhaps a grand merging or a subtle shift in environmental pressures leads to the emergence of multicellular life. This is where the tapestry of evolution truly begins to weave intricate patterns. Imagine a world where life isn't just surviving, but diversifying, exploding into a kaleidoscope of forms. Creatures swimming through vast oceans, crawling across emerging land masses, or fluttering through thickening atmospheres. This period, much like Earth's own Cambrian explosion, represents a biological grand awakening, where the basic blueprints of body plans are laid down, setting the stage for even greater complexity. But life, even complex life, is not necessarily intelligent life, nor is intelligence always a direct pathway to civilization. Intelligence, as we might define it, the capacity for abstract thought, problem-solving, and communication, often arises from specific evolutionary pressures. Perhaps a world with unpredictable seasons forces creatures to plan ahead, to store food, or to migrate vast distances. Or a world teeming with predators might favor those who can cooperate, use tools, or develop sophisticated strategies for survival. Picture a species, perhaps with dexterous limbs and curiosity-driven minds, beginning to manipulate its environment, not just react to it. They might learn to control fire, a warmth against the chill, a defense against danger, and a way to transform raw materials. They might develop intricate languages, not merely for warning calls, but for sharing complex ideas, for passing knowledge from one generation to the next, building a collective memory that transcends individual lives. From these nascent beginnings, the first whispers of civilization might emerge. Small nomadic groups, bound by kinship and shared purpose, might learn to cultivate their land, to domesticate local fauna. This agricultural revolution, wherever it happens across the cosmos, is a profound turning point. It allows populations to settle, to grow, to build. No longer just surviving day to day, they can begin to specialize, to innovate. Imagine the first permanent dwellings, then villages, then bustling towns, and eventually cities that rise like intricate sculptures from the planetary surface. The invention of writing, a way to freeze thoughts in time, to share knowledge across vast distances and generations, becomes a critical anchor for their developing culture. They begin to ask bigger questions, to map the stars above them, to understand the cycles of their world. Yet, this journey from primitive tool users to a sprawling, technologically advanced society is fraught with immense challenges, what some ponder as great filters. Think of them as colossal cosmic hurdles. Could it be that the emergence of life itself is incredibly rare? Or perhaps the leap from simple life to complex, intelligent life is almost impossible. Even once intelligence arises, the path to a sustainable, spacefaring civilization is not guaranteed. A civilization might rise to incredible heights, only to succumb to its own internal conflicts, wars that devastate its home world, or the inability to manage finite resources, leading to ecological collapse. Imagine a brilliant society, gazing up at the stars, dreaming of interstellar travel, yet unable to solve the problems of its own backyard, its ambition overshadowed by its self-destructive tendencies. The energy demands of a growing civilization, the pollution it creates, the strain on its planetary environment, these are universal pressures that any advanced society must confront and overcome. Those civilizations that do navigate these treacherous waters, learning to live in harmony with their world and with each other, might then enter a new era of profound technological advancement. They might harness the energy of their star with unimaginable efficiency, perhaps building colossal structures in space to capture its full radiance. They might develop instantaneous communication across vast distances on their world, knitting their diverse populations into a single, cohesive entity. Their gaze would inevitably turn outwards, towards the stars. They might build great interstellar vessels, not just probes, but true generational ships, carrying the hopes and dreams of their species to new stellar shores. Or perhaps they would master communication across the vast cosmic ocean, sending out signals, listening intently for any reply, a silent conversation played out across light years. Consider the immense longevity required. Our own sun has a lifespan of roughly 10 billion years, about half of which has already passed. A civilization needs a significant fraction of that time to evolve, to mature, and then to thrive. Could some civilizations survive for hundreds of millions, even billions of years, adapting and evolving far beyond our current comprehension? They might shed their biological forms, transferring their consciousness into digital realms, or integrating themselves with their technology in ways we can only imagine. They might learn to manipulate space-time itself, or even create their own mini-universes. The possibilities are as boundless as the cosmos itself, dictated only by the laws of physics and the imagination of intelligent beings. Yet, the silence of the cosmos remains. Is it because civilizations are rare, failing at one of the great filters? Or is it because they choose silence, retreating inwards, or simply developing technologies so advanced they are undetectable to us. The journey of an alien civilization is a story yet untold, a grand cosmic epic playing out on countless stages across the universe. As we ponder these silent sagas, we can't help but wonder about the next chapter, about the methods we might use to seek out these distant storytellers. And that, my dear listeners, is a tale for another gentle whisper into the cosmic night. And so, as we drift deeper into the quietude of night, our thoughts naturally turn to those distant, shimmering pinpricks of light in the velvet blackness above. Each one, a star, perhaps cradling its own worlds, its own stories. The immense, unfathomable distances separating us from these potential homes of life present a profound challenge, a cosmic silence that we, with our curious hearts and scientific minds, have long yearned to bridge. Imagine for a moment that boundless ocean of space stretching out beyond the very limits of our imagination. To truly communicate across such a chasm, we need a messenger that can travel at the absolute fastest speed known to the universe. And that, dear listener, is light itself. Or more precisely, the electromagnetic spectrum, a vast symphony of waves that includes everything from the tiny, energetic gamma rays to the gentle, expansive radio waves that hum all around us. For decades, our primary method of reaching out, and more often listening in, has been through the use of radio waves. Think of them as the most enduring, far-reaching whispers we can send or receive. Why radio waves? Well, they have a remarkable superpower. They can travel immense distances through the vacuum of space with minimal loss of energy. Unlike visible light, which can be easily absorbed or scattered by interstellar dust and gas, radio waves are much less affected, allowing them to journey across light years relatively unhindered. They are the cosmic equivalent of a clear, strong voice carrying across a vast, open field, rather than a faint candle flame flickering in a dense fog. Our earnest endeavor to detect signals from other civilizations is known as SETI, the search for extraterrestrial intelligence. For projects like SETI, the universe becomes our grand, silent concert hall, and our enormous radio telescopes, like the now-fallen Arecibo Observatory or the current FAST telescope in China, are our sensitive ears, attuned to the faintest harmonics. We're not just listening anywhere, though. Scientists have identified certain frequencies within the radio spectrum that are considered prime real estate for interstellar communication. One of the most famous is the water hole, a tranquil band between 1420 MHz and 1720 MHz. This range is particularly quiet, free from the natural cosmic background noise emitted by hydrogen atoms at 1420 MHz and hydroxyl molecules around 1665 MHz, both fundamental building blocks of water and indeed life as we know it. It's a bit like choosing a quiet, universally recognized meeting spot in a bustling city, a place where anyone looking for a conversation would naturally go. But even with the right channel, the challenges are immense. Consider the sheer power required to send a signal across dozens, hundreds, or even thousands of light years that would still be detectable by another civilization. The signal strength diminishes rapidly over distance, following what we call an inverse square law. Imagine shining a flashlight. Close up, it's bright. Far away, it's barely a speck. Scaling that up to cosmic distances means you'd need a truly monumental star-sized flashlight to make a lasting impression. Conversely, listening for a signal means trying to pick out a single faint firefly's glow in the deepest, darkest night. Beyond radio, other methods exist within the electromagnetic spectrum. Optical lasers, for example, offer another intriguing possibility. Unlike radio waves, which spread out like ripples in a pond, lasers can be focused into incredibly tight, powerful beams. This means that a laser signal could carry far more information, a higher bandwidth, and require less initial power to be detected over vast distances, provided you know exactly where to point it. It's like using a precise, highly directed spotlight rather than a broad floodlight. However, this precision is also its drawback. You need to be very, very sure where your target is, and your target needs to be looking right back at you, a cosmic game of needle in a haystack on steroids. We've also considered more exotic methods, though they remain largely theoretical for communication. Neutrinos, for instance, are tiny, ghostly particles that can pass through entire planets without interacting. They would make excellent messengers for penetrating dense matter, but the sheer difficulty of both generating a focused neutrino beam and detecting it reliably makes them impractical for interstellar chit-chat with our current technology. The same applies to gravitational waves, ripples in space-time itself, whose generation and detection require energies far beyond our current capabilities for communication purposes. Now, while SETI focuses on listening, there's also the fascinating and sometimes debated idea of METI, messaging extraterrestrial intelligence. This is where we deliberately send messages out into the cosmos, rather than just waiting for a reply. The famous Arecibo message, sent in 1974, is a wonderful example. It was a simple, binary coded picture designed to be universally decipherable, showcasing basic mathematics, chemistry, our DNA structure, our solar system, and a crude representation of humanity. More recently, the Voyager Golden Records, launched aboard the Voyager probes in the late 1970s, carried sounds and images of Earth to the stars, silent, hopeful messages in bottles cast into the cosmic ocean. But the biggest hurdle, the most profound aspect of all this, is time. Even our fastest messenger, light, travels at a finite speed, approximately 300,000 kilometers per second. While incredibly swift, the distances between stars are so immense that signals take years, decades, centuries, or even millennia to cross them. Imagine sending a message to a star system just 50 light years away. Your message would take 50 years to arrive. A response, assuming one was sent immediately, would take another 50 years to reach us. That's a 100-year round trip. A true conversation becomes impossible. It's more like exchanging incredibly slow-moving letters across an unimaginable void. We might send a message and never live to see a reply, or even for our message to arrive at its destination. It requires an almost philosophical patience, a multi-generational commitment to the grand cosmic dialogue. No, this grand cosmic challenge of communication reminds us of our place, our yearning, and the extraordinary ambition inherent in our pursuit of understanding. It's a testament to our profound curiosity, our desire to know if we are truly alone, or if other voices whisper on the celestial winds. As we consider these incredible efforts to connect across the vastness, we begin to ponder not just how we might communicate, but what we might say, and indeed, what they might say back to us, if they are listening and if they are still there. Now, let's gently drift further into the realm of possibilities beyond what we know and into the whispers of what might be. Imagine, if you will, civilizations that have lived for millions, perhaps even billions of years longer than our own. What wonders might they have conceived? What incredible feats of engineering and ingenuity could they have achieved, given such an immense sweep of time? We call these the advanced alien technologies, and they paint a breathtaking picture of what intelligence over eons can become. Picture a quiet cosmic garden, and at its heart, a magnificent star, much like our own sun, but instead of simply radiating its energy into the vast emptiness, it is embraced, not by a natural nebula, but by an intricate shimmering tapestry of solar collectors, vast beyond our comprehension. This, dear listener, is the concept of a Dyson sphere, or more accurately, a Dyson swarm. It's an idea born from the brilliant mind of physicist Freeman Dyson, who pondered how an immensely advanced civilization, needing ever-growing amounts of energy, might harness the colossal power output of its home star. Our sun, for instance, radiates enough energy in 1 second to power human civilization for hundreds of thousands of years. A Type 2 civilization on the Kardashev scale, a way we categorize civilizations by their energy consumption, would envelop its star, creating a colossal artificial shell or a dense cloud of orbital structures. Think of it as weaving a cosmic net around a luminous pearl, gathering almost every photon of light and heat, every whisper of energy that the star emits. It's not just about survival, it's about providing power for computational needs that could dwarf anything we imagine, for terraforming entire worlds, or for launching expeditions across unimaginable distances. This monumental undertaking would mean controlling energy at a scale that fundamentally alters the appearance of their star, perhaps making it appear dim or even disappear from our telescopes in certain wavelengths, its energy silently absorbed and utilized. But even with boundless energy, the universe remains vast, an ocean of stars separated by unfathomable distances. How would these advanced civilizations navigate such a boundless expanse? Perhaps they have learned to surf the very fabric of space-time. Imagine the universe not as a flat, unyielding canvas, but as a flexible, elastic sheet. What if, instead of slowly traversing this sheet, you could fold it, or even create a ripple that carries you along? This is the enchanting, albeit highly theoretical, realm of warp drives and wormholes. A warp drive, inspired by the Alcubierre metric in Einstein's theory of general relativity, proposes creating a bubble of space-time around a spacecraft. Within this bubble, the ship itself isn't moving faster than light. Instead, the space behind the bubble is expanded, and the space in front is contracted, effectively warping the journey and allowing the bubble to arrive at its destination much faster than light would take on a straight path. It's like standing on a moving walkway that is itself moving faster than you could run. The catch? Such a feat would likely require exotic matter with negative energy density, something we have yet to observe or understand. Wormholes, on the other hand, are like cosmic shortcuts, theoretical tunnels through space-time that could connect two distant points, perhaps even two different times. Again, the physics hints at the need for such exotic matter to keep these ethereal tunnels open and stable. These aren't just dreams, they are frontiers of theoretical physics, suggesting that the speed limit of light might be circumvented not by breaking it, but by bending the very road itself. Once a civilization can travel across the vast cosmic ocean, how do they speak to each other or to us? Traditional radio signals, even if powerful, are slow and diffuse, like shouting into a hurricane across miles. Advanced civilizations might employ far more sophisticated methods. Consider quantum communication, a concept rooted in the strange and wonderful world of quantum mechanics. Imagine two particles entangled across vast distances, so intimately linked that measuring the property of one instantaneously influences the other, no matter how far apart they are. While this spooky action at a distance doesn't allow for faster-than-light information transfer directly, it forms the basis for incredibly secure and potentially distributed quantum networks. Or perhaps they utilize neutrinos, tiny ghostly particles that pass through almost all matter, including planets and stars, with barely an interaction. If a civilization could generate and detect beams of neutrinos with sufficient precision and power, they could send messages across galaxies that would be virtually impervious to interference, like silent, ethereal whispers carrying secrets through the very heart of creation. Imagine sending a message through a planet, undeterred, reaching another civilization on the far side, a communication system that truly transcends physical barriers. And what of matter itself? For civilizations that have mastered energy and traversed space, the very building blocks of the universe might be their playthings. Picture molecular assemblers, machines so tiny they can build anything, atom by atom, molecule by molecule. With such nanotechnology, they could construct entire cities from raw asteroid material, self-repair starships, or even create new forms of life with exquisite precision. This isn't just manufacturing, it's creation at the fundamental level. Engineering reality from the ground up. Or perhaps they are cosmic sculptors, terraforming desolate planets, gently painting new skies, stirring new atmospheres, and seeding barren worlds with engineered ecosystems, turning a dead rock into a vibrant haven. This planetary engineering could involve adjusting orbital paths, modifying atmospheric composition to create a greenhouse effect, or even introducing specific biological agents to prepare a world for colonization. They might craft living worlds to their liking, not just adapting to environments, but reshaping them to their will, demonstrating a profound mastery over the physical universe. These incredible possibilities, harnessing stars, bending space, whispering across the void, and sculpting worlds, are not just flights of fancy. They are extrapolations of our own scientific understanding, pushed to their ultimate logical conclusions over timescales we can barely imagine. They represent the pinnacle of what intelligence might achieve, given enough time, resources, and curiosity. They are the echoes of ancient cosmic journeys, the silent testimonies to minds far beyond our current comprehension. But if such wonders exist, if these incredibly advanced civilizations have left their indelible marks upon the cosmos, how might we, here on our own little blue dot, ever hope to catch a glimpse of them? How do we search for the traces of these cosmic architects and navigators? That, dear listener, is a question that leads us to our next quiet ponderance, a journey into the methods of the great cosmic search. The universe, dear listener, is a tapestry woven with billions upon billions of stars, each a distant sun. And around so many of these stars, we've discovered worlds, planets, dancing in their celestial waltzes, a cosmic ballet of untold complexity. It's a thought that wraps around the mind like a soft, warm blanket. If life found a way here, on our blue-green sphere, might it not have found countless other ways across the vast, shimmering expanse? This question, whether we are truly alone, has whispered through human minds for millennia, a faint echo from the deepest corners of our curiosity. In our modern era, armed with telescopes that peer into the very earliest moments of time and radio antennae that listen to the distant hum of the cosmos, we've begun to systematically seek out an answer. Yet despite the sheer immensity of potential homes for life, the universe, for the most part, appears to be profoundly silent. This puzzling quiet, this profound absence of a clear, unmistakable signal, is what scientists often ponder as the Fermi paradox. Enrico Fermi, a brilliant physicist, famously asked, "Where is everybody?" If life, especially intelligent life, is common, then why haven't we detected any definitive signs of it? It's like standing in a bustling, star-filled city at night, knowing there are countless homes, yet seeing no lights on, hearing no voices. Now, our search for evidence of alien presence truly begins with listening. Imagine casting a wide net into a boundless ocean, hoping to catch a single, unique melody amidst the crashing waves. That's a bit like what the search for extraterrestrial intelligence, or SETI, does. Since the 1960s, dedicated scientists have been pointing enormous radio telescopes towards the heavens, not to see light, but to hear radio waves. These waves are the same kind of electromagnetic radiation that brings you your favorite radio programs or connects your phone to the internet. If an advanced civilization somewhere out there were to broadcast a powerful, intentional signal, perhaps a greeting, or even just the everyday chatter of their technologically advanced lives, these sensitive instruments might pick it up. What would such a signal sound like? Probably not like a language we'd understand immediately, but perhaps a pattern, a sequence of pulses, or a mathematically significant prime number sequence that clearly screams intelligence. Something that couldn't possibly be a natural phenomenon like a pulsating star or a distant galaxy. The challenge, of course, is immense. The cosmic ocean is vast, filled with natural radio emissions from swirling gas clouds, exploding stars, and energetic black holes. To discern a faint artificial whisper in this cosmic roar is akin to finding a single grain of sand on all the beaches of Earth, simply by listening for its tiny, unique hum. Sometimes we get tantalizing hints. One of the most famous examples of a potential signal, though unconfirmed, is the wow signal. In 1977, an astronomer at Ohio State University's Big Ear radio telescope detected a powerful, narrow-band radio signal that lasted for 72 seconds. It was so strong and so unique that the astronomer, Jerry Ehman, circled the corresponding alphanumeric printout and wrote "Wow" next to it. Its characteristics, its frequency, Its intensity, its fleeting nature, made it sound genuinely artificial and unlike any known natural celestial source. Yet, despite repeated attempts, it was never heard again. It remains a beautiful, mysterious cosmic riddle, a fleeting whisper that left us wondering, but without the crucial repeatability that science demands for confirmation. It's like seeing a brief, unexplained light flicker in the deep woods at night. It makes you pause, but without it happening again, you can only marvel and wonder. Beyond listening for direct broadcasts, we also search for techno-signatures, which are broader signs of technology. These aren't necessarily deliberate messages, but rather any observable indication of industrial activity or technological constructs. Could an advanced civilization, for instance, build gigantic structures around its star to harness its energy? Such a theoretical megastructure, sometimes called a Dyson sphere, would block some of the star's light and re-radiate it in infrared wavelengths. Imagine looking at a star and noticing its light dims periodically in a way that's too regular, too artificial to be a planet passing in front. Or perhaps detecting unusual heat signatures from a distant planetary system. These are the kinds of subtle cosmic fingerprints we're learning to look for, seeking anomalies that just don't fit the expected natural celestial patterns. We are, in essence, becoming cosmic detectives, searching for clues on a scale almost too grand to comprehend. But what if life isn't necessarily intelligent or technologically advanced? What if it's just simpler, microbial life, flourishing silently on a distant world? This brings us to the search for biosignatures. Our powerful new telescopes, like the James Webb Space Telescope, are not just pretty cameras, they are sophisticated cosmic spectrometers. They can analyze the light that filters through the atmospheres of exoplanets, those worlds orbiting distant stars. Each gas in an atmosphere absorbs light at specific wavelengths, leaving a unique flash fingerprint in the light spectrum. Think of it like holding a prism up to sunlight and seeing all the colors, but if you put a colored piece of glass in front of it, certain colors would be missing. Similarly, if an exoplanet's atmosphere contains certain gases in peculiar combinations, for example, a lot of oxygen alongside methane, a combination that wouldn't naturally persist in equilibrium without some ongoing biological process replenishing them, that could be a strong biosignature. On Earth, the massive amount of oxygen in our atmosphere is a direct result of billions of years of plant life continuously pumping it out. So, finding a similar disequilibrium of gases on another planet could be a telltale sign of life, a chemical signature whispered across light years. It's a subtle signature, perhaps a gentle breath from a world far away, telling us it's alive. Of course, the search for evidence sometimes brings us closer to home, to phenomena that occur within our own atmosphere. For decades, reports of unidentified aerial phenomena, or UAP, formerly known as UFOs, have captured public imagination. These are observations of objects or events in the sky that cannot be immediately identified or explained by conventional means. It's important to remember that unidentified does not automatically mean extraterrestrial. Most UAP reports, when thoroughly investigated, turn out to be misidentifications of conventional aircraft, weather balloons, atmospheric phenomena, or even clever optical illusions. However, a small fraction of these reports, particularly those from credible observers like trained military pilots, backed by multiple sensors, radar, infrared, visual, remain truly unexplained. The scientific approach to UAP is not to jump to conclusions, but to collect more rigorous data. It calls for better instruments, standardized reporting, and an open yet skeptical mind. Imagine a fuzzy photograph of something strange in your garden. It might be a new bird, a peculiar leaf, or even just a trick of the light. Science asks for a clearer image, multiple angles, and careful analysis before proclaiming anything truly extraordinary. The recent increased transparency and interest from governments and scientific bodies in gathering and analyzing UAP data is a healthy sign that these unexplained phenomena are now being approached with greater scientific rigor, shifting them from the realm of pure speculation to legitimate scientific inquiry. We seek not definitive answers yet, but better, clearer questions. And finally, we find some of the most fundamental evidence for the potential of life beyond Earth right here, delivered to our doorstep from the void. Meteorites, fragments of asteroids and comets that survive their fiery plunge through our atmosphere, occasionally contain fascinating secrets. When scientists analyze these cosmic travelers, like the famous Murchison meteorite that fell in Australia in 1969, they find something truly remarkable. Organic molecules. Not just any organic molecules, but amino acids, the very building blocks of proteins, which are essential for all known life. They also find nucleobases, the components of DNA and RNA. These aren't signs of life itself, but undeniable proof that the fundamental chemical ingredients for life are not unique to Earth. They are common, scattered throughout our solar system and, presumably, the galaxy. It's as if the universe is generously distributing its recipe cards for life, ensuring that the basic ingredients are always at hand, no matter where a star-dusted kitchen might emerge. So, as we drift through the cosmic night, we continue our patient vigil. We listen to the static between the stars, hoping for a pattern. We gaze at distant worlds, sifting their atmospheric veils for a telltale breath. We examine the fragments of cosmic wanderers, reading the chemical whispers they carry from beyond. The evidence for alien presence remains elusive, a prize yet to be definitively claimed. But the search itself, the profound act of looking and listening, teaches us so much about the universe, about the delicate conditions that allow life to blossom, and about our own place in this vast, wondrous story. And with that thought, dear listener, we gently turn our gaze from the silent expanse of space to the intricate dance of life right here on Earth, to understand what makes our own planet so uniquely vibrant. Join me next as we explore the diverse forms of life and adaptations found on Earth. As we drift further into the quiet cosmic night, our thoughts naturally turn to those who might share this boundless expanse with us. We've spoken of the conditions for life, of distant exoplanets, and the incredible scale of the universe. But what happens when we try to imagine what these potential others might be like? How do our human minds, so uniquely shaped by our own world and our own experiences, begin to conceptualize something so utterly alien? It's a fascinating dance between the known and the unknown, a delicate interplay where our imagination reaches out, yet often pulls back a reflection of ourselves. When we gaze into the vast, ink-dark canvas of space and ponder what intelligent life might look like, we're not seeing with a blank slate, but through a deeply intricate filter, the filter of human perception. It's like trying to describe the color blue to someone who has only ever known shades of gray. Our very framework for understanding is profoundly Earth-centric. Perhaps the most prominent of these filters is something called anthropomorphism. It's a wonderful, almost childlike tendency we possess to attribute human characteristics, emotions, or forms to non-human entities. Think of the stories we tell, the characters we create, even the way we sometimes talk to our pets. We give them names, ascribe intentions, imagine their thoughts. It's a shortcut our brains take, an efficient way to make the unfamiliar more comprehensible. When it comes to aliens, this often manifests in surprisingly human-like depictions. For centuries, and especially in our rich tapestry of science fiction, the aliens we've imagined often stand on two legs, possess two eyes, though sometimes larger or blacker, a mouth, and even discernible facial expressions. Be they benevolent, curious, or terrifyingly sinister. They might speak a language, understand complex ideas, and interact with us on terms we can grasp, even if those terms involve interstellar warfare or profound philosophical exchange. We project our own anatomy, our own social structures, and our own spectrum of emotions onto them, simply because our brains are wired to recognize and interpret what is familiar. It's an unconscious act, a comforting echo of ourselves in the profound silence of the cosmos. Our perception also plays delightful tricks on us through phenomena like pareidolia. This is the psychological effect where our minds, driven by an inherent need to find patterns and make sense of the world, perceive a familiar image where none actually exists. It's why we see faces in the swirling patterns of clouds, or animals in the constellations above, or even human-like features on a piece of burnt toast. This isn't a sign of delusion, but a highly evolved survival mechanism. Our ancient ancestors needed to quickly recognize a predator in the rustling leaves or a friendly face in a crowd. That same powerful pattern-seeking instinct applies to the heavens. Remember the famous face on Mars? For a time, a photograph of a Martian mesa, bathed in particular light and shadow, seemed uncannily to resemble a human face, while fascinating, further, clearer images revealed it to be nothing more than a natural geological formation. Yet, for a brief, thrilling moment, our brains, eager to find meaning and connection, had conjured a monumental visage on a distant world. Such instances highlight how readily our minds can construct evidence of alien presence from ambiguous visual data, simply because we are primed to look for it, to find patterns that resonate with our expectations. Beyond these inherent cognitive quirks, our perception is profoundly shaped by cultural influence. The stories we tell ourselves, the myths we weave, and especially the vibrant worlds of science fiction in books, movies, and television have sculpted our collective imagination. From the graceful, wise beings of Star Trek to the terrifying xenomorphs of Alien, from the benevolent E.T. to the menacing invaders of War of the Worlds, these narratives create powerful archetypes. They become the lenses through which we interpret any potential sightings or anomalous phenomena. If we've grown up with images of flying saucers, then any unusual light in the night sky might be more readily categorized as a UFO. If we've absorbed narratives of advanced alien technology, we might interpret complex crop circles as messages rather than elaborate hoaxes. These cultural templates aren't just entertainment. They become part of our subconscious framework for what aliens are supposed to look like, how they are supposed to behave, and what their intentions might be. They create a shared vocabulary for the unknown, guiding our expectations and often our interpretations. And then, there are the fundamental limitations of our own senses. We Earthlings experience the world through 5 primary senses, each finely tuned to the specific conditions of our planet. We see a narrow band of the electromagnetic spectrum, hear within a certain range of frequencies, feel vibrations, taste chemicals, and smell molecules. But what if an alien species perceived the universe through entirely different modalities? Imagine beings that communicate through intricate patterns of magnetic fields, or perceive light across a spectrum far broader or narrower than our own. What if their vision is based on heat signatures, or their hearing on quantum fluctuations? How would we even begin to recognize, let alone interact with, a life form that exists in a sensory reality utterly foreign to our own? We might be standing right next to them, or they might be communicating across the cosmos, and we wouldn't even register their presence, because our instruments and our very biology are not equipped to detect their existence. It's like a fish trying to understand the concept of air, or a bird trying to grasp the deep ocean pressure. Their worlds are so distinct that true comprehension requires a profound leap of imagination, and perhaps completely new ways of sensing. This yearning to perceive, to connect with the alien, is also deeply tied to our human psyche, our search for meaning, for companionship in the vast loneliness of the universe, and perhaps for answers to profound questions about our own existence. We project both our hopes and our fears onto these potential others, envisioning them as saviors or destroyers, teachers or conquerors. Our perception of aliens, then, isn't just about observing a distant truth. It's a mirror reflecting our own identity, our biases, our cultural narratives, and the very biological limits of our being. It's a testament to our profound curiosity and our ceaseless quest to understand what lies beyond the familiar. And in this journey of perception, we learn not only about the possibility of others, but deeply about ourselves. As we consider how our human minds frame the unimaginable, let's next turn our attention to the more tangible ways we actively listen for and seek out these elusive signals from the cosmos, exploring the methods and messages we hope to intercept in the boundless silence. And so, as we gently drift through the cosmic night, our minds often turn to that most profound of questions. Are we truly alone? The vast, inky canvas above us, studded with countless stars, whispers tales of infinite possibilities. For centuries, our gaze was limited to what our eyes could see, our wonder confined by our own planet's atmosphere. But humanity, with its boundless curiosity, could not simply stare into the abyss. We began to listen, to truly seek, to extend our senses far beyond the confines of our world. This ambitious, worldwide effort to find signs of other intelligence in the universe is what we call our global search initiatives. Imagine, if you will, our Earth as a tiny, solitary boat adrift on an immeasurable ocean, the cosmic ocean. We've cast our lines, not with hooks, but with sensitive instruments, hoping to detect a ripple, a distant echo, a signal from another vessel out there in the deep. Our primary ears for this grand endeavor are giant radio telescopes, monumental dishes that silently sweep across the heavens, patiently gathering the faint whispers of the universe. These aren't just for looking at stars. They are designed to detect electromagnetic waves, the very fabric of light and radio signals that traverse the immense distances between solar systems. Think of the electromagnetic spectrum as a vast, invisible rainbow, stretching from the energetic gamma rays to the long, languid radio waves. Somewhere within this spectrum, we believe, lies the potential for communication. Scientists have theorized about a special water hole frequency, a quiet, almost serene band of radio frequencies between the emissions of hydrogen and hydroxyl molecules. Hydrogen is the most abundant element in the universe, and hydroxyl is a component of water. The interaction of these two elements creates a unique, relatively quiet channel, much like a clearing in a noisy forest. It's a place that any intelligent civilization, if they were to thoughtfully consider a universal language, might choose as a common ground for broadcasting, a universal meeting point in the ethereal waves. We've been listening there, patiently for decades, hoping for a deliberate beacon, a pulse, a pattern that shouts intelligence across the void. But what if these distant intelligences don't use radio waves as we do? What if their messages are more subtle, more fleeting, or perhaps even more powerful in a different way? This leads us to another fascinating arm of our search: optical SETI. Instead of vast radio dishes, we turn powerful optical telescopes, like colossal, watchful eyes, towards the stars, searching for incredibly brief, intense flashes of light. Imagine a distant lighthouse not sending out a continuous beam, but a precise, coded blink. A laser pulse so powerful and brief that it stands out against the natural twinkle of a star. These pulses could be a more energy-efficient way to send a directed message across light years, a cosmic Morse code sent with light itself. We're looking for these deliberate, rapid, staccato bursts that wouldn't be produced by any known natural astronomical phenomenon. Now, our search isn't entirely random, however. It's becoming increasingly targeted, thanks to another monumental scientific achievement: the discovery of exoplanets. For a long time, the question wasn't just if there was life out there, but where it could possibly exist. Now, thanks to space telescopes like Kepler and TESS, we've found thousands upon thousands of planets orbiting other stars. An astronomical census that has utterly transformed our understanding of the universe. We've discovered super-Earths, hot Jupiters, and even planets roughly the size of our own, nestled within their stars' habitable zones, that sweet spot where temperatures might allow for liquid water, the essential solvent for life as we know it. These exoplanets become our prime targets. The next generation of instruments, like the James Webb Space Telescope, isn't just looking for these distant worlds. It's designed to peer into their very atmospheres. By analyzing the light that passes through these alien air blankets, scientists hope to detect biosignatures, chemical clues that scream life. Imagine finding an atmosphere rich in oxygen and methane, but in quantities that shouldn't naturally coexist in stable equilibrium. On Earth, it's life, constantly churning and renewing, that keeps these gases out of balance. Finding such an atmospheric disequilibrium on an exoplanet would be a thrilling hint, a tantalizing scent of life wafting across the vastness of space. We're looking for the telltale breath of a living world. And then there are the technosignatures, signs not just of life, but of technological life. What if a civilization is so advanced that it has literally re-engineered its environment on a cosmic scale? Perhaps they've built colossal structures to harness the energy of their star, known hypothetically as Dyson spheres or swarms. Such megastructures might subtly dim their star's light in ways that no natural planetary transit could explain. Or perhaps their industrial activities create waste heat or pollution that could be detected across the cosmos, a smudged fingerprint left on the universe by a thriving technological society. These are far more speculative, yet they represent another horizon in our global search, pushing the boundaries of what we conceive intelligent life might do. The sheer volume of data generated by these initiatives is staggering. An ocean of information, thousands of terabytes, flowing continuously from our radio dishes and optical telescopes. To sift through this cosmic sand for a single grain of gold, we employ powerful supercomputers and increasingly sophisticated artificial intelligence algorithms. These AIs are trained to recognize patterns, filter out terrestrial interference, and spot the anomalies that might suggest an artificial origin. It's a testament to global cooperation, too, with scientists and enthusiasts around the world contributing their computational power and expertise, a collective listening party on a planetary scale. This grand global search is a quiet, persistent endeavor, fueled by profound hope and scientific rigor. It's a testament to our innate desire to connect, to understand our place in the universe. We listen with patience, we watch with vigilance, and we analyze with meticulous care. Every passing moment is a new opportunity, every collected photon, every radio wave, a potential messenger from afar. And as we continue this silent vigil, scanning the cosmic ocean for any sign of another craft, we can't help but wonder, what would it mean for us, for humanity, if we were to finally hear a response? What would be the next chapter in our story once that first cosmic whisper is confirmed? As the universe continues its silent, majestic dance around us, we often drift into thoughts of what might lie beyond our earthly shores. Tonight, let us gently explore a profound question, one that touches the very core of our shared humanity. What if, one starlit evening, a whisper from the cosmos finally reaches us? What if the long vigil of the universe ends not with a bang, but with a signal? This, dear listener, leads us into the quiet contemplation of first contact protocols. Imagine our civilization as a tiny, fragile boat adrift on an immeasurably vast ocean, gazing up at a sky full of distant lighthouses. For decades, we have been building sophisticated ears, like the giant dishes of the SETI Institute, diligently scanning the cosmic waves for a unique melody, a message that couldn't possibly be a natural phenomenon. This passive listening, a scientific endeavor born of immense patience and hope, is our primary protocol: to listen first. It's a profound act of humility, a recognition that in the grand symphony of the cosmos, we might not yet be the loudest or even the most experienced performers. Our instruments, like the now fallen Arecibo Observatory or the network of radio telescopes globally, are designed to catch the faintest ripple, searching for non-random patterns. A series of prime numbers, a mathematical constant like pi encoded in electromagnetic waves, something undeniably intelligent, a cosmic fingerprint. But what then? What if those patient ears, after years of sifting through cosmic static, suddenly perk up? This is where the protocols truly begin to weave their intricate tapestry. It's not a simple case of answering the phone. The first step, a universally agreed upon scientific principle, would be rigorous verification. Before any grand announcement, any public declaration, independent observatories around the globe would be called upon to confirm the signal. Is it real? Is it repeatable? Could it be a terrestrial echo, a quirk of our own technology, or even a hoax? This meticulous process, outlined in international documents like those proposed by the International Academy of Astronautics, IAA, SETI Post-Detection Committee, is designed to filter out wishful thinking from genuine discovery, ensuring that when humanity finally proclaims, "We are not alone," it is with absolute scientific certainty. It's like finding a message in a bottle on a remote beach. You wouldn't just declare it a treasure before carefully examining its contents and origin, would you? Then comes the truly monumental question: who speaks for Earth? When confronted with a voice from the stars, does any single nation, any individual, possess the right to respond on behalf of 7 billion souls? Currently, there is no designated Earth ambassador. While organizations like the United Nations Office for Outer Space Affairs, UNOOSA, serve as global forums for space law and governance, they do not hold a direct mandate for first contact. The protocols emphasize the need for global consultation, a consensus among nations, scientists, ethicists, and philosophers. It's a daunting prospect, imagining the entire world pausing to deliberate on a single shared moment of destiny, transcending national boundaries and cultural differences. It calls for an unprecedented level of global unity, a shared breath held in awe and wonder. Boss, and if we decide to respond, what would we say? This leads us into the fascinating and often contentious realm of messaging extraterrestrial intelligence, or METI. For decades, humanity has occasionally sent deliberate broadcasts into space, like the iconic Arecibo message in 1974, a simple pictorial radio message depicting our numbers, our DNA, our solar system, and a stick figure of humanity. But crafting a truly universal language for an alien mind is an immense challenge. We might assume mathematics and physics are common ground, the language of the cosmos itself. Yet even how we represent these concepts could be utterly alien. Some caution against broadcasting at all, pondering the dark forest hypothesis, where a silent cosmos might be a safer one, and drawing attention to ourselves could invite unknown consequences. Others argue that hiding is futile, and that a message of peace and curiosity is humanity's best foot forward. It's a cosmic tightrope walk, balancing curiosity with prudence, a profound philosophical debate unfolding against the backdrop of infinite possibility. Beyond communication, the protocols extend to broader ethical considerations. We call this planetary protection, a concept already applied to our robotic missions to other planets like Mars. It's about preventing contamination, both ways. We wouldn't want to inadvertently introduce Earth microbes to an alien ecosystem, potentially devastating unknown life forms, nor would we wish to bring back anything that could harm our own biosphere. Furthermore, there's a deep ethical imperative to consider non-interference, a kind of cosmic prime directive, to respect the autonomy and development of any encountered intelligence, especially if it appears less technologically advanced. It is about approaching the unknown not as conquerors or exploiters, but as respectful observers, fellow travelers in the vastness. Ultimately, these first contact protocols are not about fear, but about wisdom. They are a collective human effort to prepare, to think ahead, to ensure that if the day comes when another voice joins our silent vigil, we meet it with intelligence, caution, and an open heart. They represent humanity's gentle roadmap for navigating one of the most profound moments in our story, a testament to our capacity for both scientific rigor and philosophical depth. They remind us that even in the face of the utterly unknown, we strive to act with grace and forethought. As we consider these vast possibilities, let's allow our minds to drift beyond the quiet contemplation of messages and protocols towards the very nature of those who might send them. In the soft folds of your imagination, what forms might they take? What stories might they carry? Let us gently turn our thoughts now to the diverse forms of alien life and what science suggests about their potential biology. As we drift through the cosmic ocean, mapping distant suns and their planetary companions, and listening for whispers across the interstellar void, we arrive at perhaps the most profound currents in this journey, the philosophical implications of discovery. We've explored the science of what might be out there, the tantalizing clues of biosignatures and technosignatures. But what does it truly mean for us, for humanity, if we were to lift our gaze to the stars and find another pair of eyes looking back? Imagine for a moment that quiet, world-changing moment. A signal, clear and undeniable, or a faint, unmistakable chemical signature in a distant exoplanet's atmosphere, definitively proving life beyond Earth. It wouldn't just be a scientific triumph. It would be an earthquake shaking the very foundations of our understanding, a gentle but potent tremor through every aspect of human thought, from our ancient myths to our most modern theories. One of the first, most fundamental shifts would be a deeper embrace of the Copernican principle, or the principle of mediocrity. For millennia, humanity placed itself at the very heart of creation, the special centerpiece of a divine design. Copernicus, with his sun-centered model of our solar system, began to gently nudge us from that central spot. Galileo's telescope showed us moons orbiting Jupiter, not Earth. Our galaxy, the Milky Way, was revealed to be but one of billions. And now the discovery of thousands of exoplanets, some within the habitable zones of their stars, has already set the stage. If we find life, especially intelligent life, it would be another, even more profound, cosmic nudge. It would solidify the understanding that we are not unique in our existence, not the singular outcome of cosmic evolution, but rather one thread in an unimaginably vast tapestry of life. This isn't a demotion. It's an invitation to a grander community, a realization that the universe is far richer and more diverse than our earthbound imagination could ever fully grasp. This shift in perspective would inevitably lead us to reevaluate our definitions. What is life truly? Our current understanding is deeply rooted in terrestrial biology, carbon-based, water-dependent, DNA-coded. But what if alien life is entirely different? What if we encounter organisms based on silicon or energy fields, or something beyond our current material understanding? The search for biosignatures. indicators like oxygen or methane in an atmosphere, is designed around what we understand from Earth. But an encounter with truly alien life might force us to expand our very concept of biology, pushing the boundaries of what we consider alive. It would be like trying to describe the vastness of the ocean after only ever seeing a single raindrop. Our definitions, born of our single example, might be too narrow. And then there's the question of intelligence and consciousness. Are these universal phenomena inevitable outcomes of complex systems or rare, precious jewels scattered sparsely across the cosmos? If we encounter intelligent alien life, it would be a mirror held up to our own minds. How do they think? How do they communicate? What are their values, their ethics, their understanding of the universe? Could they possess senses or cognitive abilities we can't even imagine? The very act of trying to comprehend an alien mind would deepen our understanding of our own, exposing the intricate workings of our consciousness and perhaps highlighting its limitations. It would be an invitation to ponder the very nature of existence itself, of self-awareness, and whether these are properties of matter or something more ethereal, a cosmic principle. Consider the Bata. Fermi paradox. Where is everybody? If the universe is so vast with so many stars and potentially habitable planets, why haven't we detected any definitive signs of advanced civilizations? This paradox itself is a philosophical crucible. Its possible solutions range from the sobering, perhaps life or intelligent life, is incredibly rare, making us unique and perhaps profoundly alone, to the terrifying, perhaps advanced civilizations inevitably destroy themselves, a chilling warning for our own future. Or perhaps they are simply too far, too alien, or communicating in ways we cannot yet perceive, observing a galactic preserve that includes us. The profound silence of the universe, despite our best efforts to listen for techno signatures, becomes a question, echoing through the vastness, asking us to ponder our solitude or perhaps our eventual fate. This uncertainty, this great silence, forces us to project our deepest hopes and fears onto the cosmic canvas. The Fowle-Drake equation. While a probabilistic thought experiment embodies many of these philosophical ponderings, each variable, the rate of star formation, the fraction of stars with planets, the number of habitable planets, the fraction of those that develop life, the fraction of those that develop intelligent life, the fraction of those that develop detectable technology, and the length of time such civilizations release detectable signals is not just a number. Each variable is a doorway to a different philosophical landscape. Is the leap from simple life to complex, intelligent life a probable outcome or an incredibly improbable one? Is the lifespan of a technological civilization inherently short or long-lived? Pondering these variables forces us to confront our own assumptions about evolution, destiny, and the potential pitfalls and triumphs of intelligence. Such a discovery would undoubtedly ripple through human culture, art, religion, and politics. Our religions, many founded on the premise of humanity's special relationship with the divine, would face profound reinterpretation. Our philosophies, which have long grappled with meaning and purpose in a seemingly empty cosmos, would gain new dimensions. Our art would find new muses in alien forms and narratives. Our global politics, often fragmented by terrestrial differences, might find a unifying focus, or perhaps new divisions in the face of the other. It would be a catalyst for both introspection and global unity, forcing us to consider what it truly means to be human in a universe teeming with life. And ultimately, the philosophical implications of discovering alien life are about discovery within ourselves. It's about questioning our anthropocentric biases, expanding our definitions of life and intelligence, confronting our solitude or celebrating our cosmic companionship, and reevaluating our place in the grand scheme. It's a journey not just into the depths of space, but into the depths of the human spirit, prompting us to ask, what do we truly value? What is our purpose? And what responsibilities do we carry as conscious beings in this vast, wondrous universe? As we prepare for the possibility of such a profound revelation, our search continues, guided by the light of scientific curiosity, but also by these ancient, powerful philosophical questions that hum softly beneath the surface of our inquiries, urging us ever forward. And so, what might this continued search look like? How do we prepare for a conversation that could reshape our very existence? What are the practical steps, the ethical considerations, as we reach out into the unknown? And so, as our quiet journey through the cosmic tapestry begins to gently wind down for the night, we arrive at a moment of soft reflection. We've drifted together on a silent current of wonder, touching upon the incredible, expansive possibilities that stretch far beyond our earthly home, nestled safely in the vast, shimmering dark. Tonight, we didn't just learn about distant facts. We opened a window to a profound sense of scale, a gentle reminder that our universe is a place of boundless imagination, a cradle holding secrets whispered on starlight. We contemplated the sheer quietude of it all, the immense spaces between stars, the patient orbits of unseen worlds, each holding its own gentle truth, its own unique story, far beyond our immediate grasp. It wasn't a journey meant to startle or overwhelm, but rather to softly expand the boundaries of your peaceful imagination, allowing it to unfurl like a delicate cosmic blossom. Think of the quiet hum of distant galaxies, the silent dance of cosmic dust, the patient evolution of worlds we can only just begin to picture. These aren't concepts to be rigidly memorized, but invitations to a deeper sense of wonder. A wonder that doesn't demand answers right away, but instead nurtures a soft curiosity, a gentle pondering that settles comfortably within your heart. It's a feeling of being a small, precious part of something incredibly, beautifully vast, like a single dewdrop reflecting the entire ocean, yet perfectly unique in its own right. This gentle contemplation of what lies beyond doesn't diminish the beauty and wonder of what is right here around us in our own cherished world. Instead, it subtly enriches it, adding another layer to the profound mystery of existence itself. Knowing that there might be other forms of life, other ways of being, other expressions of the universe's creativity, simply makes our own delicate blue marble, spinning gently through space, feel even more precious, more miraculously unique. It's a philosophical thought, a soft whisper that reminds us of the infinite variations the cosmos is capable of creating, all held within a boundless, tranquil embrace. And now, as the night deepens further and the stars begin their quiet, steady vigil outside your window, it's time to bring our minds back to the stillness of this very moment, back to the warmth of your covers, the soft comfort of your pillow, the gentle rhythm of your own breathing. The journey we took tonight wasn't a race to understand every single detail, but a peaceful stroll through the garden of what could be, a quiet exploration of the unimaginable possibilities that populate the universe. In this garden, every distant star, every silent planet holds its own gentle secret, its own quiet truth. And these truths, no matter how far, softly echo back to us, making our own existence here, right now, feel even more profound, more wonderfully mysterious. There's a deep, abiding comfort in this vastness, a gentle reassurance that in the infinite variety, there is room for all things, all possibilities, and most certainly for you, just as you are, exactly where you are. So let your thoughts drift now, like silent cosmic dust motes, settling softly into the quietude of sleep. There's no need to hold on to definitions or specific facts any longer. Just the feeling, the gentle echo of distant suns, the soft murmur of unseen worlds. These are the true lullabies of the cosmos. Let them wash over you, soothing and peaceful, as your eyelids grow heavy and your breath slows to a deep, even rhythm. For tonight, the journey through alien facts doesn't truly end. It simply transforms. It melts into the soft, unhurried landscape of your slumber, where the possibilities we gently touched upon will continue to unfold, not as facts to be remembered, but as soft, shimmering visions in the boundless canvas of your dreams. Perhaps you'll drift through nebulae of softest pink and blue, or land on planets made of starlight and whisper-thin clouds. In your dreams, the cosmos is your own, and your imagination a brush of pure, gentle light. There's no need for maps or instruments there, only the soft current of your subconscious carrying you safely. The wonder we explored tonight, the calm contemplation of what lies beyond, these will be your guides. They will gently accompany you, like silent, benevolent guardians, through the quiet pathways of your sleeping mind. Rest now. Let the gentle hum of the universe be your lullaby. Let the peace of the silent, star-dusted night enfold you completely. And know that the vastness is not empty, but full of quiet possibility, just waiting for the gentle exploration of your dreams. Sweet dreams, little voyager. The stars are waiting gently for you.